AC power plugs and sockets are devices that allow electrically operated equipment to be connected to the primary alternating current power supply in a building. Electrical plugs and sockets differ in voltage and current rating, shape, size and type of connectors. The types used in each country are set by national standards, some of which are listed in the IEC Technical Report TR 60083, plugs and socket outlets for domestic and similar general use standardized in member countries of IEC. Plugs and sockets for portable appliances started becoming available in the 1880s, to replace connections to light sockets with easier-to-use wall-mounted outlets. A proliferation of types developed to address the issues of convenience and protection from electric shock. Today there are approximately 20 types in common use around the world, and many obsolete socket types are still found in older buildings. Coordination of technical standards has allowed some types of plugs to be used over wide regions to facilitate trade in electrical appliances, and for the convenience of travelers and consumers of imported electrical goods. Some multi-standard sockets allow use of several different types of plugs. Improvised or unapproved adapters between incompatible sockets and plugs may not provide the full safety and performance of an approved adapter. Concepts and terminology: generally the plug is the movable connector attached to an electrically operated device's mains cable, and the socket is fixed on equipment or a building structure and connected to an energized electrical circuit. The plug has protruding prongs, blades, or pins that fit into matching slots or holes in the sockets. Sockets are designed to prevent exposure of bare energized contacts. Sockets may also have protruding exposed contacts, but these are used exclusively for earthing. To reduce the risk of users accidentally touching energized conductors and thereby experiencing electric shock, plug and socket systems often incorporate safety features in addition to the recessed slots or holes of the energized socket. These may include plugs with insulated sleeves, recessed sockets, sockets with blocking shutters, and sockets designed to accept only compatible plugs inserted in the correct orientation. The term plug is in general and technical use in all forms of English, common alternatives being power plug, electric plug, and plug top. The normal technical term for an AC power socket is socket outlet, but in non-technical common use a number of other terms are used. In British English the general term is socket, but there are numerous common alternatives, including power point, plug socket, wall socket, and wall plug. In American English receptacle and outlet are common, sometimes with qualifiers such as wall outlet, electrical outlet and electrical receptacle, all of these sometimes to be found in the same document. A socket may be surrounded by a decorative and/or protective cover called a wall plate, faceplate, outlet cover, socket cover, or wall cover. In some designs this is an integral piece with the socket itself, bought and installed as a single unit. Electrical sockets for single-phase domestic, commercial and light industrial purposes generally provide either 2 or 3 electrical connections to the supply conductors. 2-pin sockets normally provide neutral and line connections, both of which carry current and are defined as live parts. Neutral is usually very near to earth potential, usually being earthed either at the distribution board or at the substation. Line carries the full supply voltage relative to the neutral. 3-pin sockets provide, in addition, a protective earth connection for exposed metal parts of an appliance. If internal insulation should fail, a short circuit to the earthed exposed metal parts will hold them at a low potential, and should operate fuses or circuit breakers to isolate the faulty appliance from the supply. Depending on the supply system, some sockets may have 2 line connections, each at significant voltage to earth and without a neutral pin. For example, a split-phase system may have 240 V between line connections each at 120 V with respect to earth ground. But a single-phase receptacle connected to a 3-phase system may have, for example, 208 V between contacts and only 120 V between each contact and earth ground. History. Early history. When electricity was first introduced into houses, it was primarily used for lighting. At that time, many electricity companies operated a split tariff system where the cost of electricity for lighting was lower than that for other purposes. This led to portable appliances being connected to light bulb sockets using lamp holder plugs. As electricity became a common method of operating labor-saving appliances, a safe means of connection to the electric system other than using a light socket was needed. According to British author John Mellanby, the first plug-and socket in England was introduced by T. T. Smith in 1883, and there were two-pin designs by 1885, one of which appears in the General Electric Company Limited catalogue of 1889. Gustav Binswanger, a German immigrant who founded the General Electric Company Limited, obtained a patent in 1895 for a plug-and socket using a concentric contact system. An early American electrical plug-and socket was invented by Harvey Hubbell and patented in 1904. Hubbell's first design was a socket which screwed into a lamp holder, but with a separable plug with pins or blades. Other manufacturers adopted the Hubbell pattern, and by 1915 they were widespread. Gradually wall sockets were developed to supplement those that screwed into lamp holders. The Earthed consumer plug has several claimants to its invention. A 1911 book dealing with the electrical products of A. P. Lundberg and Sons of London describes the trip-in earthed plug available in 2.5 imp and 5 imp models. The pin configuration of the trip-in appears virtually identical to modern BS 546 plugs. In her 1914 book Electric Cooking, Heating, Cleaning, etc., Maud Lucas Lancaster mentions an earthed ironclad plug-and socket by the English firm of Reroll & Company. The earliest American patent application for an earthed plug appears to be January 11, 1915 by George P. Knapp, on behalf of the Harvey Hubbell Company. This patent covers the use of an earthing pin which extends further than the other two contacts to ensure that it is engaged first. The configuration of the socket was not operable with existing two-contact unearthed plugs. Other earthed sockets that are widely used today are operable with unearthed plugs. The German Schuko system plug was patented by Albert Bar 1/4 TTNER in 1926. The current American version of the earthed plug, with two parallel blades and a round earthing pin, was invented by Philip F. Leiber, while he was attending the Milwaukee School of Engineering. It is said that his landlady had a cat which would knock over her fan when it came in the window. When she plugged the fan back in, she would get an electric shock. Leiber deduced that if the fan was earthed, the electricity would go to earth through the plug rather than through the person holding it. He was issued a U.S. patent for an earthed socket in plug in 1928. As the need for safer installations became apparent, earthed three-contact systems were made mandatory in most industrial countries. Proliferation. During the first 50 years of commercial use of electric power, standards developed rapidly based on growing experience. Technical, safety, and economic factors influenced the development of all wiring devices, and numerous varieties were invented. Gradually the desire for trade eliminated some standards that had been used in only a few countries. Former colonies may retain the standards of the colonizing country. Sometimes offshore industrial plants or overseas military bases use the wiring practices of their controlling country instead of the surrounding region. Some countries have multiple voltages, frequencies and plug designs in use, which can create inconvenience and safety hazards. Hotels and airports may maintain sockets of foreign standards for the convenience of travelers. Consolidation. De facto standards became formalized as official national and international standards. Old installations with obsolete sockets exist. The International Electrotechnical Commission in 1934 established Technical Committee TC-23 for electrical fittings. Only 2 meetings were held before the outbreak of the Second World War. In Europe, since 1951 the International Commission on the Rules for the Approval of Electrical Equipment has published a standard describing the plugs and sockets used. In 1953 the CEE published Technical Report 83, which was a listing of plugs and sockets then in use. In North America the National Electrical Manufacturers Association publishes standards for plugs and sockets. Consolidation of standards eases international trade and travel. For example, the CEE 7/7 plug has been adopted in several European countries and is compatible with both CEE 7/5 and CEE 7/4 sockets, while the unearthed and unpolarized Europlug is compatible with an even greater proportion of European and other socket types. IEC 60906-1 has been proposed as a common standard for all 230V plugs and sockets worldwide but has only been adopted in South Africa so far, with a modified version used in Brazil. IEC 60906-2 recognizes the wide use of the NEMA A15 parallel blade plug and socket and recommends it for all 120V applications. Application issues. Design features of plugs and sockets have gradually developed to reduce the risk of electric shock and fire. Safety measures may include pin and slot dimensions and layout that permit only proper insertion of plug into socket, and earth pins longer than power pins so the device becomes earthed before power is connected. Electrical insulation of the pin shanks was added to some designs, to reduce live contact exposure when a plug is partially inserted in a socket. Shutters that open only for the correct plug prevent foreign objects from contacting live slots. Some types include fuses and switches. Earthing. A third contact for a connection to earth is intended to protect against insulation failure of the connected device. When earth distribution systems became common, earlier unearthed socket types were either replaced with new standards, or revised to include an earthing pin. Different types of plugs are used for different IEC appliance classes. The assigned class depends on whether or not the device is earthed, and the degree of insulation it incorporates. Class I, for example, refers to earthed equipment which requires a third contact in the plug and socket, while Class II refers to unearthed equipment protected by double insulation. Polarization, where the building wiring system defines a neutral conductor that is connected to earth. It is an advantage for appliance designers to preserve that distinction. This requires a plug that can only be connected in one way to the socket, so that the energized and neutral conductors are not interchanged. In most designs, such polarized plugs cannot be mated with non-polarized sockets. Wiring systems where both circuit conductors have a significant potential with respect to earth do not benefit from polarized plugs. Polarization is maintained by the shape, size, or position of plug pins and socket holes to ensure that a plug fits only one way into a socket. The switch of the appliance is then connected in series with the energized wire. For an appliance such as a toaster, putting the exposed heating wires on the neutral side of the switch provides a small measure of extra protection against electrical shock. Similarly, lamps with Edison's screw bases will connect the screw shell of the lamp socket to the neutral conductor. Interchange hazards. Plugs and sockets are designed as a system to meet standards for safety and reliability. Some types of socket may accept more than one type of plug. Where this is an official, approved intention of the socket design, all the approved combinations will be tested to the applicable safety standards. Occasionally, plug and socket combinations may allow power to flow but may not meet product standards for mating force, earthing, current capacity, life expectancy, or safety. Improvised or user-modified connectors will not meet the product safety standards. Adapters between different standards can overcome mechanical incompatibility. Physical compatibility does not ensure that the appliance and socket match in frequency or voltage. Appliance connections and extensions, so that manufacturers need not build, distribute and maintain many similar appliances differing only in the type of plug fitted. A common strategy is to provide an IEC 60320 inlet on the appliance and a detachable power cord to allow connection of the appliance to the socket. The appliance need only to be tested to the power inlet. Some types of appliance require the consumer to also change a switch to adapt to different voltages or frequency. In addition to sockets permanently attached to building wiring, extension cords are used for temporary connections when a socket is not within convenient reach of an appliance's power lead. Portable equipment such as gardening power tools may have a male power inlet compatible with a connector at the end of an extension cord. This allows one long cord to be shared among several tools, and so saves storage space and cost for the consumer. Multiple small appliances may be connected to sockets on a power strip which can also include switching, surge voltage and overcurrent protection. A power strip equipped with different series of plug and sockets can act as an adapter for imported equipment. Special purpose plugs and sockets. Special purpose sockets may be found in residential, industrial, commercial or institutional buildings. Examples of systems using special purpose sockets include clean earth for use with computer systems, emergency power supply, uninterruptible power supply for critical or life support equipment, isolated power for medical instruments, tools used in wet conditions, or electric razors, balanced, or technical power used in audio and video production studios, theatrical lighting, sockets for electric clothes dryers, electric ovens, and air conditioners with higher current rating. Special purpose sockets may be only labeled or colored to identify a reserved use of a system, or may have keys or specially shaped pins to prevent use of unintended equipment. Types in present use. There are two basic standards for voltage and frequency in the world. One is the North American standard of 120 volts at a frequency of 60 Hz, and the other is the European standard of 220 Euro 240 volts at 50 Hz. The differences arose for historical reasons as discussed in the article Mains Electricity. The IEC maintains a web page giving arbitrary letter designations for generally compatible types of plugs. The IEC web page does not identify the national standards corresponding to each plug letter. Letter designations were given in a 1998 U.S. government publication, intended as a guide for Americans traveling or working in other countries. The letter codes are often used as a de facto naming standard when comparing different AC power plugs, especially when describing travelers' adapters. Physically identical sockets may be connected to voltages incompatible with an appliance. The letter codes do not identify all the variants of a plug and socket family for different current ratings or for special purposes. In Europe, the European Committee for Electrotechnical Standardization publishes a list of approved plug and socket standards used in the member countries. Argentina IRAM 2073 and 2071 and compatible types. The plug and socket used in Class A1 applications in Argentina is defined by IRAM. The applicable standards are, IRAM 2073 2-poles plugs with earthing contact for domestic and similar purposes, rated 10A and 20A, 250 VAC. And IRAM 2071 2-pole socket, outlets with earthing contact for 10A and 20A, 250 VAC, for fixed installations. It is similar in appearance to the Australasian and Chinese plugs. The pin length is same as the Chinese version. The most important difference from the Australian plug is that the Argentinian plug is wired with the line and neutral contacts reversed. In Brazil, a very similar plug and socket are still commonly used for high-power appliances like air conditioners, dishwashers, and household ovens. Since Brazil adopted the NBR 14136 standard, which includes a 20A version, the original motivation to use the so-called Argentinian plug has ceased to exist. Australian standard ASN ZS 3112. The plug used in Australia, New Zealand, Fiji, Tonga, Solomon Islands, and Papua New Guinea, has an earthing pin and two flat current-carrying pins forming an upside-down V shape. The flat blades measure 6.5 by 1.6 ohm and are set at 30 degree to the vertical at a nominal pitch of 13.7 ohm. Australian and New Zealand wall sockets almost always have switches on them for extra safety, as in the UK. An unearthed version of this plug with two angled power pins but no earthing pin is used with small double-insulated appliances, but the sockets always include an earth pin. There are several ASN ZS 3112 plug variants, including ones with larger or differently shaped pins used for devices drawing 15, 20, 25 and 32A. These sockets accept plugs of equal or of a lower current capacity, but not of higher capacity. For example, a 10A plug will fit all sockets but a 20A plug will fit only 20, 25 and 32A sockets. Australia's standard plug socket system was originally codified as standard C112, which was superseded by ASA 3112 in 1990. The requirement for insulated pins was introduced in the 2004 revision. The current version is ASN ZS 3112-2011, approval and test specification are Euro plugs and socket outlets. Brazilian standard NBR 14136, Brazil, which had been using mostly Class II Euro plugs, and NEMA 1 the Euro 15 and NEMA 5 a Euro 15 standards, adopted a modified version of IEC 60906-1 as the national standard in 1998 under specification NBRA 14136. These are used for both 220-volt and 110-volt regions of the country. There are two types of sockets and plugs in NBR 14136, one for 10 OA, with a 4 ohm pin diameter, and another for 20 OA, with a 4.8 ohm pin diameter, the latter used for heavier appliances such as microwave ovens. NBR 14136 was not enforced or encouraged in that country until 2007, when its adoption was made optional for manufacturers, becoming compulsory on January 1, 2010. It helped domestic consumers that most of Class II plugs fitted in the new NBR 14136 sockets. However, very few private houses have an earthed supply, and even if a 3-pin socket is present, it is not safe to assume that all 3 terminals are actually connected without testing. Most large domestic appliances are sold with the option to fit a flying earth tail to be locally earthed, although many consumers are unsure how to use this and so it is not fitted, effectively using the equipment as Class 0. British and compatible standards. BS 546 and related types. BS 546, 2-pole and earthing pin plugs, socket outlets and socket outlet adapters for AC circuits up to 250V describes 4 sizes of plug rated at 2A, 5A, 15A and 30A. The plugs have 3 round pins arranged in a triangle, with an earthing pin. The plugs are polarized and unfused. Plugs are non-interchangeable between current ratings. Introduced in 1934, the BS 546 type has mostly been displaced in the UK by plugs and sockets to the BS 1363 standard. According to the IEC, some 40 countries use Type D and 15 countries use Type M. Some, such as India and South Africa, use standards based on BS 546. BS 1363. BS 1363 13A plugs, socket outlets, adapters and connection units is the main plug and socket type used in the United Kingdom. According to the IEC, it is also used in over 50 countries worldwide, many of which have national standards based on BS 1363, including Ireland, Malaysia, Singapore, and Saudi Arabia. This plug, commonly called a 13OA plug or 13OM plug, has 3 rectangular pins forming an isosceles triangle. As the BS 1363 socket is conventionally used with ring circuits, the plug has a fuse to protect the appliance flexible cable from overload. BS 4573. In the United Kingdom and Ireland, there is a 2-pin plug and socket for use with electric shavers and toothbrushes. The plug has insulated sleeves on the pins. The BS 4573 socket is suitable for use in dry areas only, so is rarely used. It is more usual to find shaver supply units meeting BSEN February 5, 6, 1558, which include an isolation transformer and usually accept multiple 2-pin plug types including BS 4573, Europlug and Australian, and sometimes a 115V output for 2-pin US plugs. CEE 7 standards and Europlug, a number of standards based on 2 round pins with centers spaced at 19 ohm are in use in continental Europe and elsewhere. The sockets are generally compatible with the CEE 7/16 Europlug as well as the corresponding plug type. The Europlug has 2 pins 4 ohm diameter spaced 18.5 ohm on centers at the base. The pins are slightly flexible, which allows the Europlug to fit several types of CEE standard sockets. CEE 7/4, Type F. Series 7/4, commonly called Schuko socket, has a recessed round shape with 2 symmetrical round sockets and 2 earthing clips on the sides of the socket. The Schuko connection system is symmetrical and unpolarized in its design, allowing line and neutral to be reversed. Its dimensions are compatible with CEE 7/5 except that the female earth contact is omitted. The socket also accepts Europlugs and Series 7/17 plugs. It supplies up to 16A. The current German standards are DIN 49441 1972-062 pole plugs with earthing contact 10A 250 var per mil and 10A 250 var euro, 16A 250 var 1/4, and DIN 49440-1 2006-012 pole socket outlets with earthing contact, 16A 250 VAC. It is also used in Albania, Austria, Bosnia and Herzegovina, Bulgaria, Chile, Croatia, Denmark, Estonia, Finland, Greece, Hungary, Iceland, Indonesia, Iran, Italy, Latvia, Lithuania, Luxembourg, Republic of Macedonia, Republic of Moldova, the Netherlands, Norway, Pakistan, Portugal, Romania, Russia, Serbia, Slovenia, South Korea, Spain, Sweden, Turkey, Ukraine, and Uruguay. It is also defined as the Class I plug in Italian Standard Serie 23-5. Schuko is an abbreviation for the German word Schutzkontakt, which means protective contact. In this case, protective refers to the earth. Some countries, including Portugal, Finland, Denmark, Norway and Sweden, require child-proof socket shutters. The German Schuko standard does not have this requirement. CE 7/5, Type E. French standard NFC 61-314 plugs and socket outlets for household and similar purposes defines a round plug with two round pins measuring 4.8 by 19 mm, spaced 19 mm apart and with a hole for the socket's earth pin. This standard is also used in Belgium, Poland, the Czech Republic, Slovakia and some other countries. Although the plug is polarized, there is no universally observed standard for placement of the line and neutral. However, the Czech standard recommends the line wire to be on the left side when facing the socket. Add to that the French convention changed circa 2002 from nothing particular, to, if the earth pin was at the top then the line hole in the socket would be on the right looking at the socket. However, the socket may not necessarily be installed with the earth pin at the top. Packaging in France of said sockets is normally marked with correct orientation of the cables. Polarized pre-fitted plugs on appliances are therefore connected with the brown to the right pin and the blue to the left, the earth being connected to the hole at the top of the plug. CE 7/4 plugs are not compatible with the Series 7/5 socket because earthing in the CE 7/5 socket is via a round male pin permanently mounted in the socket. CE 7/7. To bridge the differences between German and French standards, the Series 7/7 plug was developed. It is polarized to prevent the line and neutral connections from being reversed when used with a French CE 7/5 socket, but allows polarity reversal when inserted into a German CE 7/4 socket. The plug is rated at 16A. It has earthing clips on both sides to connect with the Series 7/4 socket and a female contact to accept the earthing pin of the CE 7/5 socket. It is used in almost all European countries. Currently, appliances are sold with non-rewirable CE 7/7 plugs attached. This means that the plugs are now identical between countries like France and Germany, but the sockets are different. CE 7/16 Europlug. This 2-pin plug, rated a 2.5A, is popularly known as the Europlug. The plug is unearthed and has two round 4mm pins, which usually converge slightly towards their free ends. It is not rewirable and must be supplied with a flexible cord. It is defined by Sinelic standard EN 50075 flat non-rewirable 2-pole plugs, 5A 250V, with cord, for the connection of Class II equipment for household and similar purposes, which has national equivalents in most European countries, as described in IEC 60083. Because it is unpolarized, it can be inserted in either direction into a socket, so line and neutral are connected arbitrarily. The separation and length of the pins allow it safe insertion in most CE 7/5, CE 7/4 Schuko, Israeli, CE 7/7, Swiss, Danish and Italian sockets. Most modern UK dedicated shaver sockets designed to accept BS4573 shaver plugs also accept Europlugs for applications requiring less than 200 mA. The Europlug itself is used in Class II applications throughout continental Europe. It is also used in the Middle East, most African nations, South America, Asia as well as Russia and the former Soviet republics, such as Ukraine, Armenia, Georgia, and many developing nations. It is also used alongside the BS 1363 in many nations, particularly former British colonies. CE 7/17. This plug also has two round pins, but the pins are 4.8 ohm in diameter like CE 7/5 and CE 7/4, and the plug has a round plastic or rubber base that stops it being inserted into small sockets intended for the Europlug. Instead, it fits only into large round sockets intended for CE 7/5 and CE 7/4. The base has holes in it to accommodate both side contacts and socket earth pins. It is used for large appliances, and in South Korea for all domestic non-earthed appliances. It is also defined as the Class II plug in Italian Standard Serie 23-5. It can also be inserted into Israeli SI-32 with some difficulty. The Soviet GOST 7396 standard includes both the CE 7/17 plug and a variant with shape of the CE 7/17 plug but with the 4.0 ohm diameter pins used in the Europlug. Unearthed sockets. Round unearthed sockets have no earth provisions and consequently have been phased out in most countries. Countries using the CE 7/5 and CE 7/4 standards vary in whether unearthed round sockets are still permitted in environments where the need for earthing is less critical. Some countries prohibit use of unearthed and earthed sockets in the same room, in the insulated room concept, so that people cannot touch an earthed object and one that has become live, at the same time. For example, in Germany, unearthed sockets are rare, found only in very old installations, whereas in the Netherlands they are common in dry areas such as in bedrooms or living rooms. Standards also vary between countries as to whether child-resistant shutters are required. The depth of the sockets also vary between countries and age. Older sockets are so shallow that it is possible to touch the pins of a plug when the plug is inserted deep enough to get electrical power on the pins, while newer sockets are deep enough to protect from this kind of accident. Depending on the country and the age of the socket, these may have 4.0 or 4.8 ohm sockets. The latter accept CE 7/5 and CE 7/4 plugs in addition to Europlugs, though without earth connection. Adapters, trailing sockets, and power strips designed to accept only Europlugs with 4 ohm pins may also have plastic barriers in place to prevent CE 7/17, Shuko or French plugs from entering. The earthed CE 7/5 and CE 7/4 sockets were specifically designed to not allow insertion of an unearthed round plug from older appliances that were earthed via other means, but the CE 7/17 plug has notches to allow it be used in those sockets by devices not requiring an earth. Round unearthed sockets and plugs are for Class 0 insulation and are not a kind of Europlug. Europlugs are for Class II insulation and designed specifically to plug in CE 7/5 and CE 7/4 sockets. Danish Section 107-2D Unearthed. This Danish standard plug is described in the Danish Plug Equipment Section 107-2D1 standard sheet. Unlike the French CE 7/5 plug, the earthing pin is on the plug, not in the socket. The Danish socket need not be recessed to protect the earthing pin. The Danish standard provides for sockets to have child-resistant shutters. The Danish socket will also accept the Series 7/16 Europlug or Series 7/17 Shuko French hybrid plug. Series 7/4, Series 7/7, and earthed CE 7/5 French plugs will also fit into the socket but should not be used for appliances that need earth contact. The current rating on both plugs is 13A. A variation of the Danish plug is for use only on surge-protected computer sockets. It fits into the corresponding computer socket and the normal socket, but normal plugs deliberately don't fit into the special computer socket. The plug is often used in companies, but rarely in private homes. There is a variation for hospital equipment with a rectangular left pin, which is used for life support equipment. Traditionally all Danish sockets were equipped with a switch to prevent touching live pins when disconnecting the plug. Today, sockets without switch are allowed, but then it is a requirement that the sockets have a cavity to prevent touching the live pins. The shape of the plugs generally makes it difficult to touch the pins when disconnecting. Since the early 1990s, earthed sockets have been required in all new electric installations in Denmark. Older sockets need not be earthed, but all sockets, including old installations, must be protected by earth fault interrupters by July 1, 2008. As of July 1, 2008, wall sockets for French 2-pin, female earth CEE 7/5 are permitted for installations in Denmark. This was done because no electrical equipment sold to private users is equipped with a Danish plug. Sockets for the Schuko were not permitted until November 15, 2011. It could also result in a bad connection of the pins, with resultant risk of overheating and fire. Many international travel adapter sets sold outside Denmark match CEE 7/16 and CEE 7/7 plugs which can readily be used in Denmark. Denmark has allowed CEE 7/4 Schuko sockets from November 15, 2011. Italy. Italian earthed plugs and sockets are defined by the standard Serie 23-50 which superseded Serie 23-16. This includes two models rated at 10A and 16A that differ in contact diameter and spacing. Both are symmetrical, allowing the line and neutral contacts to be inserted in either direction. This plug is also commonly used in Chile and Uruguay. The 10A plug has pins which are 4 mm in diameter, the centers spaced 19 mm apart. The 10A socket can accept Europlugs. The 16A plug has pins which are 5 mm in diameter, the centers spaced 26 mm apart. The 16A socket used to be referred to as per la forza motrice or sometimes industriale. Large appliances are usually sold with Schuko plugs, so 16A non-rewirable plugs are usually used only in adapters and power cords. Those appliances are always earthed, so unearthed 16A plugs are now very uncommon, and only a few brands still sell them in rewirable version. The dual standards were initially adopted because in Italy, up to the second half of the 20th century, electricity used for lamps and that used for all other purposes was at two different voltages, sold at different tariffs, charged with different taxes, accounted with separated electricity meters, and sent on different wire lines that ended with different sockets. Even though the two electric lines were gradually unified beginning in the 1960s, many houses kept twin wires and twin electricity meters for years thereafter. The two gauges for plugs and sockets thus became a de facto standard which is now standardized under CEI 23-50. Older installations often have sockets that are limited to either the 10A or the 16A style plug, requiring the use of an adapter if the other gauge needs to be connected. Numerous cross adapters were used. Unearthed Europlugs are also in common use. They are standardized in Italy under Serie 23-5 and fit most of the appliances with low current requirement and double insulation. Appliances with Series 7/7 Schuko French plugs are often sold in Italy too. However, most sockets will not accept them since the pins of the Series 7/7 Schuko French plugs are thicker than the Italian ones. Adapters are standardized in Italy under Serie 23-57, they are commonly used to connect Series 7/7 plugs to Serie 23-16/7 sockets, but they cannot exceed 1500 watts and could make an unsafe connection in some cases. The current Italian standards provide for sockets to have child-resistant shutters, Italian multiple standard sockets. In modern installations in Italy it is usual to find sockets that can accept more than one standard. The simpler type has a central round hole and two figure-8-shaped holes above and below. This design allows the connection of both 10A and 16A plugs and the Europlug. The advantage of this socket style is its small, compact face. VIMAR brand claims to have patented this socket first in 1975 with their Ascent model. However, soon other brands started selling similar products, mostly naming them with a generic term Presa Passo that is now of common use. A second, quite common type looks like a Schuko socket, but adds a central earthing hole. This design can accept CE7/4, CE7/7, and Italian 10A plugs. Some of these sockets may also have figure-8-shaped holes to accept Italian 16A plugs as well. Its drawback is that it is twice as large as a normal Italian socket and the price is higher. For those reasons Schuko and Bipasso Schuko socket are rarely installed in Italy. Other types may push compatibility even further. The VIMAR brand universal socket, for example, accepts CE7/4, CE7/7, Italian 10 and 16A plugs, and also NEMA A15 plugs. Soviet standard GOST 7396 Car1 unearthed. This Soviet plug, still widely used in modern Russia, has pin dimensions and spacing equal to the Europlug, but lacks the insulation sleeves. Unlike the Europlug, it is rated 6A. It is a round body like the French CE7/5 or flat body with a round base like CE7/17. The round base has no notches. The pins are parallel and do not converge. The body is made of fire-resistant thermoset plastic. The corresponding 6A socket accepts the Europlug, but not others as the 4.5A holes are too small to accept the 4.8 pins of CE7/4, CE7/5 or CE7/7 plugs. There were also molded rubber plugs available for devices up to 16A similar to CE7/17, but with a round base without any notches. They could be altered to fit a CE7/5 or CE7/4 socket by cutting notches with a sharp knife. Swiss SEV 1011. Switzerland has its own standard which is described in SAVAT 1011. This plug is similar to the Europlug, except that it has an offset earth pin and the pin shanks are not necessarily insulated, so plugs partially inserted into non-recessed sockets present a shock hazard. However, since January 1, 2013, only partially insulated plugs of type CE7/16 and of type J plugs are allowed to be imported and distributed to reduce the risk of electric shocks. Sockets used in kitchens, bathrooms and other wet areas are recessed, while those used elsewhere are not. Some plugs and adapters have a tapered form and can be used in either environment, while others will fit only the non-recessed sockets. Swiss sockets accept Swiss plugs or Europlugs. There is also a non-earthed 2-pin variant with the same pin shape, size, and spacing as the SAVAT 1011's line and neutral pins, but with a more flattened hexagonal form. It fits into Swiss sockets and Series 7/16 sockets, and is rated 10A. The SEV 1011 earth pin is offset by 5 ohm from the center line of the line and neutral pins. The system is modular and allows variants with 5 pins for 3 phases and square pins for 16A. Above 16A, equipment must either be hardwired to the electrical supply system with appropriate branch circuit protection, or connected to the mains with an appropriate high-power industrial connector. IEC 60906-1. In 1986, the International Electrotechnical Commission published IEC 60906-1, a specification for a plug and socket that look similar, but are not identical, to the Swiss plug and socket. This standard was intended to one day become common for all of Europe and other regions with 230 V mains, but the effort to adopt it as a European Union standard was put on hold in the mid-1990s. The plug and socket are rated 16A 250 VAC and are intended for use only on systems having nominal voltages between 200 V and 250 VAC. The plug pins are 4.0 ohm in diameter, line and neutral are on centers 19 ohm apart. The earth pin is offset 3.0 ohm. The line pin is on the left when looking at a receptacle with the earth pin offset down. Shutters over the line and neutral pins are mandatory. The only country to have officially adopted the standard is South Africa as SANS 164-2. Brazil adopted a non-compliant version of IEC 60906-1 as the national standard under specification NBR 14136. The NBR 14136 standard has 2 versions, neither of which has pin dimensions or ratings complying to IEC 60906-1. Use at 125V is permitted by NBR 14136, which is against the intention of IEC 60906-1. China CPCS-CCC. The standard for Chinese plugs and sockets is set out in GBAR 2099.1 at €2008 and GBAR 1002 at €2008. As part of China's commitment for entry into the WTO, the new CPCS has been introduced, and compliant Chinese plugs have been awarded the CCC mark by this system. The plug is 3-wire, earthed, rated at 10A, 250 and used for Class 1 applications. A 16A version also exists. The Australian plug fits, though the pins on the Chinese plug are thinner and 1 ohm longer. China also uses American-Japanese NEMA A15 sockets and plugs for Class II appliances. The voltage at a Chinese socket of any type is 220. Israel SI32. The plug defined in SI32 is unique to Israel. There are two kinds, one with flat pins, and the other with round ones. The pre-1989 system has 3 flat pins to form a Y shape. Line and neutral are spaced 19 ohm apart. The plug is rated at 16A. In 1989, the standard was revised to use 3 round 4.5 ohm pins in the same locations, allowing the socket to accept the Euro plugs used in Europe and Israel for non-earthed appliances. Sockets made since 1989 accept both flat and round pins for compatibility with both old and new plugs. Pre-1989 sockets which accept only old-style plugs are very rare in Israel. SI32 plugs have no sleeve insulation, so when an SI32 plug is partially removed its prongs may still be connected to the socket increasing the chance of electric shock. This plug is also used in the areas controlled by the Palestinian Authority, the West Bank and the Gaza Strip. North American and IEC 60906-2. Most of North America, and some of South America, use connectors standardized by the National Electrical Manufacturers Association. The devices are named using the format NEMA NMX, where N is an identifier for the configuration of pins and blades, ohm is the maximum amperage, and X is either P or R. For example, NEMA A15 is a configuration Type 5 receptacle supporting 15 amps. P and A versions are designed to be mated. The prefix L is added for the locking types. A 15-amp 120-volt two-pole grounding plug is designated NEMA L5-15P. Twist locking types are used for additional protection from accidental disconnection, or to prevent interchange with parallel blade types. For some configurations, the arrangement of pins will differ slightly for the different current ratings, to prevent accidental mating of devices with a higher current draw than the receptacle can support. IEC 60906-2 uses NEMA 5-15. A brief description of some common NEMA standards appears below. A more comprehensive list, with more detail, appears in the NEMA connector article. NEMA 1-15 ungrounded. NEMA 1 plugs are compatible with both NEMA 1 receptacles and NEMA 5 receptacles. NEMA 1 is ungrounded, while NEMA 5 is grounded. The plug has 2 parallel blades. Early versions were not polarized, but almost all plugs are polarized today via a taller neutral blade on the plug and corresponding plug on the receptacle. Ungrounded NEMA 1 outlets are not permitted in new building construction in the United States and Canada, but can still be commonly found in older construction. Allowed replacement of NEMA 1 receptacles varies by local code. NEMA 5-15 grounded. The NEMA 5-15 plug has 2 flat parallel blades like NEMA 1-15, but also adds a ground pin. It is rated 15A at 125 volts. The ground pin is longer than the line and neutral blades, so the device is grounded before the power is connected. Both current-carrying blades on grounding plugs are normally narrow, since the ground pin enforces polarity. NEMA 1-15 plugs are also compatible with NEMA 5-15 sockets. The 5 to 15 socket is standard in Canada, the United States, Mexico and Panama. It is also used in Central America, the Caribbean, North and South America, Japan, Taiwan, the Philippines and Saudi Arabia. This socket is recommended in IEC standard 60906-2 for 120 volt 60 Hz installations. Looking directly at an NEMA 5 to 15 socket with the earth at the bottom, the neutral slot is on the left, and the line slot is on the right. Sockets may be installed in any orientation. In 46 of the 50 United States and all of Canada, tamper-resistant sockets are now required in new residential construction. These prevent contact by objects like keys or paper clips inserted into the socket. In stage lighting, this connector is sometimes known as PBG for parallel blade with ground, Edison or Hubbell, the name of a common manufacturer. NEMA 5 to 20. As NEMA 5 amperages increase, changes are made to the plug's neutral so that it will not fit into lower amperage receptacles. Some higher amp receptacles are designed to accept multiple shapes for the neutral blade, so that both higher and lower draw devices are compatible with it. The NEMA 5-20 AAP variant has a horizontal neutral blade. The receptacle has a T-slot for the neutral blade which accepts either 15 AA parallel blade plugs or 20 AA plugs. NEMA 5 to 30 and 5 to 50 are rare. L5-30 and L5-50 twist lock is more common. The non-locking versions are physically incompatible with 5 to 15 and 5 to 20, as the hot neutral blades are farther apart. NEMA 14 to 30, A30OA, 3-wire single-phase earthing socket is often used for electric clothes dryers. 240 volts from the split-phase system is used for the heating elements, and the motor and controls run on 120 volts. These plugs have blades that are rather larger than NEMA 5 to 20, are more widely spaced, and are angled so as to prevent using the wrong plug in the wrong circuit. NEMA 14 to 50, A50A 3-wire single-phase earthing socket is usually installed in kitchens and used for electric cooking ranges and ovens. As for dryers, lighting and motors run on 120 V and the main heating element is connected for 240 V. Many plug-in electric cars use this type of socket for recharging in the owner's garage. JISC 8303, Class 2 unearthed. The Japanese plug-in socket appear physically identical to NEMA 1-15. The Japanese system incorporates stricter dimensional requirements for the plug housing, different marking requirements, and mandatory testing and approval by METI or JIS. Older Japanese sockets and multi-plug adapters are unpolarized. The slots in the sockets are the same size and will accept only unpolarized plugs. Japanese plugs generally fit into most North American sockets without modification, but polarized North American plugs may require adapters or replacement non-polarized plugs to connect to older Japanese sockets. In Japan the voltage is 100 V, and the frequency is 50 Hz or 60 Hz. Therefore, some North American devices which can be physically plugged into Japanese sockets may not function properly. JISC 8303, Class I earthed, Japan also uses an unearthed plug similar to the North American NEMA 5 to 15. However, it is less common than its NEMA 1 to 15 equivalent. Since 2005, new Japanese homes are required to have Class I earthed sockets for connecting domestic appliances. This rule does not apply for sockets not intended to be used for domestic appliances, but it is strongly advised to have Class I sockets throughout the home. TIE 3-pin plug TIS 166-2549. TIE Industrial Standard 166-2547 and its subsequent update TIS 166-2549 stipulated a modification of the IEC 60906-1 plug, replacing prior standards which were based on NEMA 1 to 15 and 5 to 15, as Thailand uses 220 V electricity. The plug has two round power pins 4.8 ohm in diameter and 19 ohm in length, insulated for 10 ohm and spaced 19 ohm apart, with an earthing pin of the same diameter and 21.4 ohm in length. located 11.89 mm from the line connecting the two power pins. It was designed to provide compatibility with prior hybrid 3-pin sockets, which accept NEMA 1-15, NEMA 5-15 and Euro plugs, all of which have been variably used in Thailand. The hybrid socket is also defined in TIS 166-2547, in addition to a plain 3-round pin socket, with plans to replace the former and phase out support for NEMA-compatible plugs. Sockets are polarized. The plug is similar to, but not interchangeable with, the Israeli SI32 plug. Comparison of standard types, compatible with unearthed plugs. A Euro deep wall socket prevents human contact with pins. A Euro CE7/7 specifies an earthed hybrid plug that will fit into both the CE7/4 and CE7/5 sockets. CE7/17 specifies an unearthed hybrid plug that will fit into both the CE7/4 and CE7/5 sockets. One-type letters are from the International Electrotechnical Commission website that provides classification letters similar to a United States Department of Commerce publication that sees widespread but not universal use to differentiate plug and socket types based on rough mechanical compatibility. Most common household plugs have an associated letter. 2. There are some CE7/17 plugs with special shape which are polarized when used with CE7/5 sockets. 3. Plug can only be inserted one way with French CE7/5, but lack of wiring convention means that the system is not polarized. 4. Newer sockets can accept unearthed Euro plugs. 5. Fuse type technically possible and existing, but rare and unusual. 6. Import of plugs with non-partially insulated pins no longer allowed after 2012. 7. BS 4573 itself does not explicitly specify a current rating for a compliant plug. CBS 4573 section of British and compatible standards. Multi-standard sockets. Sockets that take a variety of plug types can be found in places where market size or local market conditions make a specific plug standard impractical to implement. Sockets may accept plugs to various European, Asian, North American, British or Australian standards, but not Indian or South African. Multi-standard sockets do not safeguard against devices being damaged by the wrong voltage. Users must know the voltage requirements of their appliances as well as the prevailing local voltage. In some multi-standard sockets the aperture size for NEMA plugs is the same for both line and neutral, which may defeat the polarization of NEMA 1 plugs. In a socket designed to accept both NEMA and BS 1363 plugs, the lower right contact should be connected to the line wire for BS 1363 plugs, but the neutral wire for NEMA plugs, so safe wiring of these devices for universal use is not possible. Some of these sockets have one or more earth holes to allow 3-pin plugs. On properly wired circuits, the earth contact will be connected to earth. However, they cannot provide earthing to all types of plugs, as is the case of Schuko and French plugs. Those designed to accept British plugs have pin apertures which are larger than allowed by BS 1363, and are therefore not legal for UK or Irish use. Adapters. Adapters allow travelers to use portable devices with foreign sockets. Adapters allow physical connection between plug and socket but do not change voltage or frequency. A voltage converter is required for electrical compatibility in countries with a different voltage than the device is designed for, if it is not designed for variable voltage input. Obsolete types, old Spanish sockets. Some older industrial buildings in Spain used sockets that took a plug rated for higher current and had 2 flat contacts and a round earth pin, somewhat similar in design to the ones found on American plugs but larger in size. The 2 flat contacts are spaced further apart than on an American plug. No domestic appliances were ever sold with these plugs. The line and neutral measure 9 by 2 ohm, and are 30 ohm apart. All 3 pins are 19 ohm long, and the earth pin is a cylinder of 4.8 ohm diameter. Original American Hubbell plug and receptacle. An early American electrical plug and socket was invented by Harvey Hubbell and patented in 1904. Hubbell's first design was a socket which screwed into a lamp holder, but with a separable plug with pins or blade. The 1906 Hubbell catalogue shows this plug with a flush mounting socket for use in wall or floor. Other manufacturers adopted the Hubbell pattern, and by 1915 they were widespread. American 125V, 15A/250V, 10A Australian style. A patent for this obsolete American plug-and socket was filed in 1915 under U.S. Patent 1,179,728. It predated the NEMA sockets and plugs. The plugs and sockets used in countries such as Argentina, Australia and China are based on this type. Split current voltage ratings. Many older North American sockets have two different current and voltage ratings, most commonly 10A250V/15A125V. This is to do with a peculiarity of the National Electrical Code from 1923 to the 1950s. Originally, sockets were rated at 10A250V, because the NEC limited lighting circuits to 10A. In 1923, the code changed to allow lighting circuits to be fused at 15A, but the previous 10A rule still applied to circuits over 125V. The higher voltages were rarely used for lighting and appliances. Most sockets with this rating are of the T-slot type. US perpendicular socket. Another obsolete socket, made by Bryant, 125V15A and 250V10A rating. An NEMA 5 at €20 125V20A or 6 at €15 250V15A plug with a missing earth pin would fit this socket, but a NEMA 2 at €20 plug is slightly too big to fit. The upper slots as seen in the illustration connect to silver-colored wiring screws on the upper side, and the lower slots connect to brass-colored wiring screws on the lower side. In Australia, the same or similar T-configuration sockets are used for DC power sockets, such as in standalone power systems, on boats and in police vehicles. Polarity is inconsistent. In the former Soviet Union this socket was and still is commonly used for wiring in places where the voltage is lowered for safety purposes, like in schools, filling stations or in wet areas, and is rated 42V10AAC. Such an unusual connection is intended specifically to make the connection of standard high voltage equipment impossible. US combination duplex socket. The parallel and tandem socket accepts normal parallel NEMA 1 of €15 plugs and also tandem NEMA 2 of €15 plugs. Both pair of socket are fed internally by the same supply. A more recent and fairly common version of this type is the T-slot socket, in which the locations of the tandem and the parallel slots were combined to create T-shaped slots. This version also accepts normal parallel NEMA 1 of €15 plugs and also tandem NEMA 2 of €15 plugs. Incidentally, a NEMA 5 of €20, a NEMA 6 to 15 or 6 of €20 plug with a missing earth pin would fit this socket. This type has been unavailable in retail shops since the 1960s but still available from the manufacturer Leviton, not for new installation, for replacement only. UK obsolete types. Several types of plugs and sockets were commonly used in the UK before the adoption of national standard types. Old Greek sockets. Called tripolyki, the standard had 3 round pins, similarly to the Swiss SEV 1011 and to the post-1989 Israeli tie type, virtually abandoned by 1995. Previous to the large-scale adoption of Schuko plugs, this was the only way to use an earthed appliance. Unusual types, lamp holder plug. A lamp holder plug fits into the bayonet cap or Edison screw socket of a lamp holder in place of a light bulb and enables an electrical appliance to be powered from a wall or ceiling light fitting. As mentioned in early history above, they were first introduced in the late 1800s and in use to the 1960s in situations where wall sockets were scarce and sometimes non-existent in some rooms. Also, as in some countries electricity was supplied on a split tariff basis with electricity for lighting being charged at a lower rate than that for other purposes, lamp holder plugs enabled the consumers to reduce their electricity costs and were thus in broad use. Lamp holder plugs were and are rarely fused. In the UK, lighting circuits are protected with a 5A or 6A fuse or circuit breaker. Wiring regulations in the UK and some other countries no longer approve lamp holder plugs because of the risks of overheating and fire. Edison screw lamp holder adapters are still easily found and commonly used in the Americas. NEMA €2 and €20. These unearthed plugs with two flat parallel blades are intended for use on 240-volt circuits. The €2 has coplanar current blades, and is used for 240 V service at 15 A, while the €20 has the blades at 90 degree relative to each other and is used for 240 V service at 20 A. NEMA 2 plugs and sockets are rare because they are unearthed and so, no longer permitted for new installations. They have no neutral. In some cases these plugs can be inserted into incorrect voltage sockets. Prior to the adoption of the NEMA standard, a plug nearly identical to the €20 was used for 120 V at 20 A. That obsolete plug would fit into 5 €20 and 6 €20 sockets, which supply different voltages, but will not fit in NEMA 2 €20 socket. Soviet adapter plugs. Some appliances sold in the Soviet Union had a flat unearthed plug with an additional pass-through socket on the top, allowing stacked arrangement of plugs. This design was very helpful, but somewhat unsafe, as the brass cylinders of the secondary socket were uncovered at the ends, recessed only for 3 ohm and provided bad contact because they relied on the secondary plug's bisected expanding pins. The pins of the secondary plug could not be inserted into the cylinders completely, and were accessible through a 5 ohm gap between the primary and secondary plugs. UK Walsall gauge plug. Unlike the standard BSA 1363 plugs found in the UK, the earth pin is on a horizontal axis and the line and neutral pins on a vertical axis. This style of plug socket was used by university laboratories and the BBC, and is still in use on parts of the London Underground for 110 VAC voltage supply. They were also used in the Ministry of Defence main building on circuits powered from the standby generators to stop staff from plugging in unauthorized devices, for example kettles. Italian Ticino brand Magic Security Connector. This style of connector, produced by Italian manufacturer Ticino, appeared in the 1960s and was intended as an alternative to the Europlug or CEI 23-16/7 connectors then in use. The socket is an almost rectangular socket, with one or more lateral key pins and indentations to prevent inverting the polarized plug, or connecting plugs and sockets with different current ratings. At least 4 models were produced, 3 single-phase general-purpose connectors rated respectively 10A, 16A and 20A, plus a 3-phase industrial connector rated 10A. All of them have different key pin positionings so plugs and sockets cannot be mismatched. The socket is closed by a safety lid which can be opened only with an even pressure on its surface, thus preventing the insertion of objects inside the socket. The contacts are blades positioned on both sides of the plug. The plug is energized only when it is inserted fully into the socket. The obvious drawback of the system is that it is not compatible with Europlugs. As household appliances were never sold fitted with these security plugs and the use of adapters would defeat all of the newly introduced safety features, once this system is adopted all standard plugs must be cut off and replaced with the appropriate security connector. However, the Magic security system had some success at first because its enhanced safety features appealed to customers. Standard connectors of the day were considered not safe enough. The decline of the system occurred when safety lids similar to the Magic type were developed and then applied to standard sockets by third brands and by Ticino itself. In Italy, the system was never definitively abandoned and, though rarely seen today, is still marked as available in Ticino Euro unregistered trademark S products catalog. In Chile, 10A Magic connectors are commonly used for computer laboratory power networks, as well as for communications or data equipment. This allows delicate electronics equipment to be connected to an independent circuit breaker, usually including a surge protector or an uninterruptible power supply backup. The different style of plug makes it more difficult for office workers to connect computer equipment to a standard unprotected power line, or to overload the UPS by connecting other office appliances. In Iceland, magic plugs were widely used in homes and businesses alongside Europlug and Schuko installations. Their installation in new homes was still quite common even in the late 1980s. Single-phase electric stove plugs and sockets. The plugs and sockets used to power electric stoves from a single-phase line have to be rated for greater current values than ones for three-phase system because all the power has to be transferred through a single line. Electric stoves are often hardwired to the electrical supply system, connected to the mains with an appropriate high-power industrial connector or with non-standard high-power proprietary domestic connector. In Russia, an electric stove can often be seen connected with a 25 to 32A connector. Industrial and multiphase. Plug and socket systems intended for high current, high voltage or polyphase industrial equipment, as well as additional contacts and larger contacts, may also include features to improve the security and safety of use. For example, a high-power plug may include a locking ring or twist lock feature to prevent accidental disconnection in use. A socket may include a mechanical interlock that prevents insertion or removal of a plug unless the local safety disconnecting switch is open. Plugs may include special measures to contain an arc generated during disconnection. Plugs used for equipment in wet locations may include small supervisory contacts that check the integrity of the earthing conductor. See also: AC adapter, DC connector, IEC 60309 high-power industrial and polyphase connectors, mains electricity by country lists voltage, frequency, and connector types for over 200 countries, plug load, polyphase system, stage pin connector, references. External links, Glossary of Standards Terms, Change to UK Electrical Wire Colours 2004, Household Electrical Safety Handbook, Electrical and Mechanical Services Department, Hong Kong, Guidance Notes for the Electrical Products Regulation, IEE History of Australian Power Connectors, South Africa ISCOM, Wiring a Plug, Overviews and Diagrams, Overview of types of plugs and sockets, pictures including many variations on the plugs and sockets described here, including disassembled units,